थॉट फॉर द डे। मेरे राम राय मुझते कछो न होए, आपे करता आपे कराए, सर्व निरंतर सोए रहाओ। अर्थात, ओ माई सोवरियन लॉर्ड, आई कांट डू एनीथिंग एट ऑल बाय माई सेल्फ। He himself is the creator, he himself is the cause, he pervading deep within all. Pause. Unit 2 Solutions. Part 3 Colligative properties. Colligative properties, the properties which depend upon the number of solute particles irrespective of their nature, are called colligative properties. There are four colligative properties. First is relative lowering of vapor pressure, second one is depression of freezing point, third one is elevation of boiling point, fourth one is osmotic pressure. We are going to cover first three here. The first one is relative lowering of vapor pressure. We know already lowering of vapor pressure. According to Raoult law, P1 will be equal to P naught 1 x1, and lowering in vapor pressure of solvent, that is delta P1 is delta P1 will be equal to P naught 1 minus P1, and we are putting the value of P1 here from equation 1, and P naught 1 x1, we are taking P naught 1 common, and we will get P naught 1 and 1 minus x1, equation number second. Now, but 1 minus x1 is equal to x2. Put this value in equation 2 and we will get delta P1 will be equal to x2 P naught 2. Equation 3 can also be written as P naught 1 minus P1 and P1, that will be equal to x2. Hence, relative lowering of vapor pressure, the fraction P naught 1 minus P1 divided by P1 is called relative lowering of vapor pressure, is equal to the mole fraction of solute. Hence, it is a colligative property. Note, in a solution containing several non-volatile solutes, the lowering of vapor pressure depends upon the sum of the mole fraction of different solutes. Now, calculation of molecular mass of solute. We know delta P1 divided by P naught 1, that is equal to delta means P naught 1 minus P1 and P naught 1, that is equal to x2. We have already derived this equation, but x2 is equal to N2 divided by N1 plus N2, and putting this equation 5 in 4, then we will get P naught 1 minus P1, P naught 1, that will be equal to N2 divided by N1 plus N2. And but for dilute solution, N1 is the for solvent and N2 is for a solute. Solute is is a per dilute solution. Solute is present in very small amount. Therefore, we can take approximation N1 plus N2 nearly equal to N1. Putting after taking this approximation, we have equation number 7, and after putting the value of n2 and n1, we will get equation number 8, because n is equal to the weight in gram divided by molar mass. N2 will be W2 upon M2 and N1 will be W1 upon M1. Putting these values, we get the equation number of 8. Hence, we can calculate the molar mass of solute very easily here. That is M2 can be calculated by applying equation 8. Elevation of boiling point. What is, we should know what is boiling point. The temperature at which vapor pressure of a liquid become equal to atmospheric pressure is called its boiling point. Elevation of boiling point. The boiling point of a solvent increases when a non-volatile solute is added to it. This is known as elevation of boiling point. And the cause of elevation of boiling point is when a non-volatile solute is added to a solvent, its vapor pressure becomes less. Hence, the solvent is to be heated more now to make the vapor pressure equal to the atmospheric pressure. We have studied this topic already, lowering in vapor pressure. Okay, and the plot of vapor pressure versus temperature for pure solvent and solution is shown in figure. And the vapor pressure curve of solvent is always above the vapor pressure curve of solution, because vapor pressure of solvent is always greater than vapor pressure of solution. Let's see the graph. We have gone along x-axis temperature and along y-axis is the vapor pressure, and it is the 1 atmosphere that it does. The first curve is for solvent, second one is for solution, and it is the boiling point of solvent, boiling point of solution, and it is the TB, boiling point of solvent, and pure solvent, and then for boiling point for solution, and delta V TB is the elevation in boiling point. And let TB not vapor pressure of pure solvent, and TB vapor pressure of solvent in solution, TB elevation of boiling point, then TB will be equal to TB minus T naught B. And calculation of molar mass of solute experiment have shown that dilute solutions for dilute solution, the elevation of boiling point TB is directly proportional to the molar concentration of solute in solution. That is, TB is directly proportional to molality. And for eliminate the proportionality, we'll have to introduce constant, that is Kb. TB will be equal to Kb into m. Here m is equal to molality. Kb constant of proportionality, boiling point elevation constant, or molar elevation constant, or ableoscopy constant. What is the definition? When m is equal to 1, then Kb will be equal to Tb. Therefore, Kb will be equal to the elevation in boiling point when molality is unity. And putting the value of molality in equation 2, we get the formula for calculating the molar mass of solute. Solute is Mb, and A is taken for solvent here. And note, elevation constant may be defined as the elevation in boiling point when molality of solution is unity. The unit of Kb is kg per mole. Depression in freezing point. We should first know what is freezing point. The temperature at which solid and liquid state of a substance have same vapor pressure is called its freezing point. Freezing depression in freezing point. The freezing point of a solvent decreases when non-volatile solute is added to it. This is known as depression in freezing point. And cause of depression in freezing point: solute particle does not fit into the crystal of the solvent because of differences in size. The solute essentially remains in solution and block other solvent from fitting into the crystal lattice during the freezing process. The plot of vapor pressure versus temperature for pure solvent and solution is shown in figure. And again same, the vapor pressure curve for solvent is always above the vapor pressure curve of solution, because vapor pressure of solvent is always greater than vapor pressure of solution. And let T not F vapor pressure of pure solvent, TF is vapor pressure of solvent in solution, TF depression in freezing point. Then TF will be equal to T delta TF will be equal to TF minus T not F. Let us see the graph. And all these things are shown in the graph. And calculation of molar mass, again the experiment have shown that for dilute solution, the depression in freezing point is directly proportional to the molar concentration of solute in solution. That is, TF is directly proportional to molality, or delta TF is directly proportional to molality. Therefore, delta TF will be KF and M. M is the molality, KF is the constant of proportionality called depression constant or cryoscopy constant. And by using this, we can calculate, putting the value of molality, we can calculate the molar mass of solute here. Solvent 1 is used, and for solute 2 is used here. KF again defined, may be defined by putting molality unity. There are some numerical problem based on, check your knowledge. First is numerical is based on relative lowering of vapor pressure. The vapor pressure of pure benzene at a certain temperature is 0.850 bar. A non-volatile non-electrolyte solid weighing 0.5 gram when added to 39 gram of benzene, molar mass 78 gram per mole. Vapor pressure of the solution then is 0.845 bar. What is the molar mass of solid substance? We have P naught 1 and P1, M1 and W2 as shown. W1, and we know the formula for relative lowering of vapor pressure. Putting all the values in this formula, we get this, and finally we get M2 170 gram per mole. Now, second numerical is for elevation in boiling point. 18 gram of glucose is dissolved in 1 kg of water in a saucepan. At what temperature will water boil? At 1.013 bar. Kb for water is given 0.52 Kelvin kg per mole. And to solve this numerical, we have moles of glucose can be calculated. Weight in grams divided by molar mass, that is 0.1 mole. Number of kilogram of solvent 1 kg, therefore molality is 0.1 mole per kg. And for water, change in boiling point, that will be delta TV will be kb into m, that will be equal to 0.52 kg per mole, that multiplied by 0.1 mole molality, and we get 0.052 Kelvin. Since water boil at 373.15 gallon Kelvin at 1.013 bar pressure, therefore the boiling point of solution will be 373.15 plus 0.052, that is 373.202 Kelvin is the answer. And next numerical is for depression in freezing point. uh, 1 gram of non-volatile non-electrolyte solute dissolved in 50 gram of benzene lowered the freezing point of benzene by 0.40 Kelvin. The freezing point depression constant for benzene is this 5.12 kg per mole. Find the molar mass of solute. We know the formula for depression in freezing point, and putting all these values of kf, w2, m2, and then we will get m2 here, and that will be 256 gram per mole. And thank you for attending the lecture.